Hello. Today we're going to talk about the real world. Now in the real world, it has lots of data, so we're going to model some real world data and we're going to use some scatter plots. Now, there's 3 steps to doing this. 1, plot the points. 2, draw a line of best fit. And 3, write an equation for that line. Now because whenever you do this, depending on which points you pick, because scatter plots aren't always on an exact line in the real world, I'm going to have you guys use decimals so we can compare to what's recommended. Make sure it's in the right area. So let's use this as an example. Whether you are climbing a mountain or flying in an airplane, the higher you go, the colder the air gets. The table shows the temperature in the atmosphere at various altitudes. So they're going to give us a table with altitude and temp. And the first thing you want to do is decide, okay, what is my independent variable? What's dependent? What decides what? And as I'm looking at this, I'm saying, see, the altitude kind of depends on the temp. Since the higher you go, the temp goes down. You have to go up altitude. Altitude's going to be my x, temp's going to be my y. So the temperature depends on what altitude we're at. So altitude is going to be x. Now, next we're going to have to look at, when I graph this, what would be a good scale? So a good scale for altitude, 0 to 4,000 or 5,000. How about 500 feet? So if this is 0, 500 feet. This will be 1,000. This will be 2,000. This will be 3,000. 4,000. Okay? And then temp, we're looking at the highest of 15, lowest of 7. I'm thinking let's go up by 2. So 2, 4, 6, 8, 10, 12, 14, 16. Okay. So the very first step, step 1, plot the points. So let's plot these points. The first one is 0, 15. So 0 left and right, up 15. So right about here. The next one is 1,013. So over 1,000, up 13. Next one, 2,011. 3,009.1. About here. 4,007.1. Okay. Now this is pretty nice because they are all pretty close to this nice line. You can tell it's a negative correlation, but they're in pretty close to a line. Not much for variance. Sometimes you'll find them where there's quite a bit of variance. Other situations, not so much. But the second step is draw a line of best fit. So the best thing you can do is to pick 2 points on the end. Don't pick them close enough. You want to find the middle of that line. Generally speaking, the points on the ends of your scatter plots are going to give you a farther spread. So I'm going to pick those 2 points and draw a line connecting those 2. Something like that. So they're pretty close. They're not quite on that line of best fit, but most points are pretty close. And the line's in the middle of those points pretty close. So, all right. So next, step 3, the last step, write an equation of the line. So once we have an equation, we can just use what we know for writing equations of lines. 1, since I circled a couple points and my line's going to go through those 2 points, those are the 2 points I'm going to use to find my slope. So slope equals y2. So if I'm using this point and this point, y of the second point will be 7.1 minus the y of the first point, which is 15, over the x of the first point, which is 4,000, minus 0. So 7.1 minus 15 is about 7.9 over 4,000. Now, because these fractions are going to have decimals in them, I recommend turning them into decimals, because then it'll be easy to compare if you're close. So I'm going to change this 7.9 divided by 4,000 equals 0.001975. So 0.001975. Okay, so that's my slope. Once I have my slope, remember I just need to use a point for my equation. It just so happens that I have my y-intercept. So in that case, I can write an equation in slope-intercept form saying y equals, my slope is 0.001975 x plus 15. And now I have an equation of that best fit. So if I want to predict, and why do we do this? We do this so that we can have predictions. If I want to predict what the temperature will be at 5,000, I can now use this equation to solve for what that would be at 5,000. So at 5,000, that's my x, I would write y will equal 0.001975 times 5,000 feet plus 15. So we'll grab a calculator. And we'll go 0.001975 times 5,000 equals 9.875. And then plus 15. Oh, I did make a mistake. Shoot. This was a minus 7.9, which means that's a minus slope, which that's a minus. And so I'll have a minus 9.875 plus 15. So now I will, if that's a minus, I will go 15 minus 9.875, and that'll give me y equals 5.1. 5.125. So about 5.1 degrees is what we should expect at this point. And 5.1 is about right here, and that looks pretty close. So thanks a lot. Be careful of those negative signs. Good luck. Remember, plot the points, draw a line in the middle of all those points, and then pick 2 points on each end that are a ways away from each other, and write an equation with those 2 points. Good luck. Have a great day.